Today, me and my partner Hazmi would like to present about how differentiation can apply in real life. So we're gonna talk about today is physics. As we all know, there are many things that we can relate to mathematics, like many things. For example, when we try to buy some stuff, we need to calculate our money before we even go to the grocery to buy some things. Another example, if we want to go to some other places, we need to calculate how how many kilometers that we need to go to get to the destination. So, but we're not gonna talk about that today. Today we're gonna talk about how differentiation is related to physics. So, how is this happen? Um, Differentiation can concern with things like speeds and accelerations, slopes and curves. This we calculate the rate changes for these kind of things, and they are defined locally. That's it.
So next, for the problem statement, we're gonna discuss about the distance, velocity and acceleration. We have found two questions that we're gonna discuss. So for the first question, the velocity of an object is given by the equation Vt equal to square root 4 plus t, where the velocity V is measured in meters. The time t is measured in seconds. Find the distance traveled by the object for the first 5 seconds. Question 2. A particle moves along a straight line in the positive direction of the x-axis with velocity given by the equation v equal to 2 square root x meter. Assuming that x in bracket t equal to 0, find the time t the particle takes to cover the first 100 meter of the path.
Another problem statement is one fine day on an unused airport runway, a high-end sports car conducted a 0 to 400 km per hour performance test. Its velocity changed according to the following function. V equals to A in bracket 1 minus e power of t divided by b, where A is 128 miles per hour per second and B is 13.31 seconds. How long did it take the car to reach 400 km per hour? In 101 and 111.111 miles per second.
So for the problem solution, for the question 1, which is given that the velocity is positive for t greater than 0, the total distance traveled for the time interval is expressed by the integral, where u is the inner variable which has no impact on the computation of the integral. For the integration use, which is dt equals to 2 square root in bracket 4 plus u power of 3 divided by 3 equals to 2 over 3 in bracket square root of 4 plus t power of 3 minus 8. Then substituting t equals to 5, we have 2 over 3 in bracket square root 4 plus 5 power of 3 minus 8, which is we get 2 over 3 multiplied by 19, which is the answer for this question is 12.7 meter.
The problem solution of the second question is the equation of motion of the particle has the form of v equals to dx dt equals to 2 square root of x. And now we have a simple differentiation equation that describes the particle position as a function of time, separating the variables and integrating of both side yield, which is dx square root of x equals to 2 dt, and it will goes to integrate dx square root of x equals to 2 and integrate again dt which is 2 and square root of x 2 plus c, and it will goes to x equals to t plus c. As we done that, it follows from the initial condition x that the c equals to 0. Hence, the particle moves according to the law. So, it is x equals to t2. It is easy to see that t equals to 10 seconds when x is 100 meters. So the problem solution for question 3 is to, firstly, we need to use the given equation to solve the part which is v equals to a in bracket 1 minus e power of negative t over b, and then we collect the terms e e power of t over b negative equals to 1 minus v over a. V is velocity, a for do a bit, and then we go to the under the power of e with a natural logarithm, which is negative t over b equals to ln 1 minus v over a, and then we going to do a bit more algebra. T equals to negative b ln 1 minus v over a, and then we put the numbers, all of it. T equals to negative 13.31 second ln, and then put all the numbers and then answer, and then calculate the answer. That's all. In conclusion, all these calculations are really important to our lives. Even though some people neglect how not important this is, but I think it's a big thing for us to stay our really good lifestyle. If this calculation would not happen, then our lives would be hard, or hard, yes. Our life will be really difficult in the future. So I would like to give thanks and appreciate the people that come up with these ideas to solve our daily problems, and we need to use these kind of methods to make our lives better now and in the future, especially during this pandemic. We need to do things really carefully. We need to look at the details, how the things that will happen. So that's it from us. Thank you. I would like to thank you to everyone who's been really helpful during our project. Without wasting time, let's get started to our project.